So good afternoon po. We are Group 7 and we're gonna present all about air compressors.
So, ayun, magandang hapon sa ating lahat. Mag-start sa aming pag-present about sa air compressor. Mayroon muna tayong icebreaker. So, ang title ng ating game is Basa ko, kanta mo, baby. So, familiar naman kayo dyan kay baby, kay Boss King yan. So, bali, ang mechanics ng ating game is may babasahin akong lyrics ng kanta and then nasabihin nyo lang kung anong title. And yung makakahula kung anong title nito is bibigyan may prize sa ating BOD. So ready na ba ang lahat? Anyone? So yun. So yung ating prize yung BOD na natin ang bahala. So mag-raise hand lang kung may nakakaalam na ng ating title. So para sa ating unang kanta. Ano ating lagay, hindi mapalagay. Ako'y nasasaktan pag hawak mo kanyang kamay. Sa kanya ka sa tanghali, akin ka sa gabi. Pagdilat sa umaga, yo wala ka na sa tabi. Mayroong kahati, gusto kita na mapasakin. Kung pwede lang ba sana sa kanya kita nakawin. At lagi mong iisipin kung hindi ka para sakin, wag mo lang kakalimutan na ikay mahal pa rin. So wala pa nakakaalam kung ano yung yun. Sayang, price ko.
Ikaw po. Paul.
So, lang.
Paulit po nag-chat po kasi.
Wala. Wala ba?
Pet. Pet.
Kapit. Tama. Ang unang nanalo ay si Rainiel Makuha. So next ay unang last naman ay ano ba to? Anong pipiliin mo? Blanco ako. Anong mas gusto mo? Pagkasama ka, yun ang nasa isip.
Dota
Anong
ako.
Sino? Ano?
Dota ako.
Sino? Ano pa ulit? Paulit.
Dota ako.
Tama. So, ang nanalo ng ating anay. So, yan. Yung mga price niya is chat nyo na lang kay Boss Almac sa ating BOD para maklaim niyo yung price. Thank you.
So, good afternoon. I'm Dieter Mendoza here to present air compressor with my group mates. So, for the introduction, an air compressor is a versatile mechanical device designed to convert power into kinetic energy stored in pressured air. This compressed air can be utilized in various applications across industries and households. Air compressors are essentially for powering and paint sprayers, as well as for task like inflating tires, operating machinery, and providing a clean source of compressed air for industrial processes. They come in a range of size and types from small portable units for personal use to a large stationary system for industrial purposes, catering to diverse need with efficiency and ri- reliability. Next slide po. So these are the types of compressor. You can refer to your module page 107, figure 7.1 for clear image. So next slide po. So I'm going to discuss about the dynamic compressors. So they are non-positive displacement compressors that use centrifugal or axial force to accelerate and convert the velocity of the gas to pressure. It's like a fast spinning machine that takes in air, squeeze it, and then shoot it out with more force, and are great for handling a lot of air quickly and efficiently, making them handy in places where a strong, fast stream and compressed air is needed. And by the way, nakakita na ba kayo ng air compressor? Paki-react na lang kung oo. Nakakita na ba kayo ng air compressor? So kung nakakapagpa-vulcanize kayo or nakakapunta kayo ng vulcanizing shop or mga paint shop, yun yung machine na yung natunog pag nag-i-store ng pressure na siya, tapos i-release na. So next slide po. So first is the centrifugal compressors. A centrifugal compressor is a type of dynamic compressor that uses a rotating impeller to compress air or gas. So for reference, you can go to page 108, figure 7.2. So it's first is the here is the simple breakdown. First is the impeller. Imagine a fast spinning wheel with blades. That's the impeller. When it spins, it pulls in a air or gas. Next is the centrifugal force. As the impeller spins, it creates a centrifugal force that flings the air outward. Next is the compression. The compression outward flung air is then directed into a diffuser where it slows down and the pressure release. This compressed air is then ready for various uses such as powering tools or industrial processes. Next po. So, additional, centrifugal compressors are known for their efficiency and reliability, and they are often used in application where a continuous high volume flow of compressed air or gas is required. They are used in industries like petrochemical, power generation, and manufacturing. And here's some video to explain it further.
A centrifugal compressor is comprised of the following key components. Compressor housing. Impeller. Ambient air inlet. Outlet. A centrifugal compressor uses an impeller to draw in gas at the hub and accelerating it radially by centrifugal force through a circular looped housing. The housing acts as a diffuser that converts high-speed, low-pressure air leaving the impeller to high pressure, low speed air.
So yun ganun mag-function yung centrifugal compressor. So next naman is axial compressors. An axial compressor is another type of dynamic compressor distinct from the centrifugal compressor. And here's a simple breakdown. So axial flow in axial compressor, airflow parallel to the axis of rotation. Picture it like a series of fans stuck on a shaft, each with rotating blades. So for reference, you can go to page 109, figure 7.5. Makakita kayo dun ng illustration ng axial compressor. So rotating blades. The compressor has rows of rotating blades called rotors and stationary blades called stators. The rotating blades, similar to an aircraft propeller, draw in air and push it along the axis. Next. So, compression stage. Axial compressors often have multiple stages, with each stage consisting of a set of rotating and stationary blades. As air passes through each stage, it gets compressed further. High efficiency. Axial compressors are known for their high efficiency, especially in application where a continuous and high volume of compressed air is required. Next. So to add more, axial compressors are commonly used in aircraft engine, power plants, and certain industrial processes where a streamlined and efficient flow of compressed air is crucial. However, it's not used as frequently as the reciprocating and centrifugal compressors because of its high initial maintenance cost. All compressors can be rated by dividing discharge pressure by the suction pressure, and this is called the compression ratio. And here's another video to explain it further.
MAN Diesel and Turbo is the world's leading supplier of industrial axial flow compressors. Various types of axial flow compressors are available to meet the specific requirements of different industrial sectors. Depending on the frame size, a single axial flow compressor may have a suction capacity of up to 1.5 million cubic meters per hour and be able to compress this flow to a maximum pressure of 25 bar. For example, all the air inside the Cologne Cathedral, which at 516 feet is the third tallest church building in the world, could be exhausted in around 16 minutes. The basic design of an axial flow compressor is similar to that of a fan. Blades are mounted around a shaft. In order to increase the effect, several of these blade rows are arranged axially, one behind the other. This axial stage group is often combined in a machine with one or more downstream radial stages in order to further increase the discharge pressure. A compressor of this type, such as the AR Max 1 shown here, is known as an axial radial compressor. The axial and the radial part are mounted on a common shaft, and the gas, normally air, flows through them in turn. An intercooler can be installed in between, which increases the efficiency of the compression process. Let's now take a look at the axial stage group. As they rotate, the blades strike the gas, guiding it backwards and also compressing it. This process generates a flow along the axis. That's why the machine is called axial flow compressor. The outlet casing guides the compressed gas to the outlet nozzle. Compression raises the temperature of a gas, which in turn somewhat reduces the density and increases the volume. As the downstream compression process would require more energy, The intercooler reduces the temperature of the gas before it enters the radial part. Axial flow compressors are able to compress extremely high volume flows, but the maximum feasible pressure ratio is limited. On the contrary, centrifugal compressors can only process lower volumes, but deliver higher pressures. Since the gas in the AR Mach 1 has already lost sufficient volume through compression in the axial part, the downstream radial part is perfectly suited for bringing the gas to a high discharge pressure. MAN Diesel and Turbo has been designing and manufacturing axial flow compressors since 1950, either in air separation, nitric acid production, as blast furnace blowers, or in refinery applications. These machines have been verified hundreds of times and proven over decades. Coal liquefaction is a future-oriented application that extracts synthetic fuels and other chemicals from coal. The process requires large amounts of oxygen. Large air separation units are therefore becoming increasingly important. To extend its leading position in this area, MAN has developed AirMax. This compressor train consists of an AR Mach 1 axial flow compressor as a main air compressor, an integrally geared centrifugal compressor, and a driving steam turbine in the middle. In its blading, AR Mach 1 combines for the first time the benefits of conventional industrial compressors with those of aero engine compressors. This makes it extremely robust, as well as uniquely compact and efficient.
So yon, ganun nagpa-function yung axial compressor. Nag-promote pa ng brand nila. So next is the ejector. A device used to suck the gas or vapor from the desired vessel or system. Similar to vacuum pump or compressor, but without the need of mechanical parts. So this is a simple illustration of ejector. So next. So an ejector is a device that uses a high-speed fluid such as a gas or a liquid to create a low-pressure region and entrain another fluid or substance into the flow. So here's a simple breakdown. High-speed fluid flow, the ejector typically has a nozzle through which a high-speed fluid is expelled. This fluid can be steam, air, or another gas or liquid. Next is the low pressure zone. As the high-speed fluid exits the nozzle, it creates a region of low pressure. This low pressure zone is where the ejector draws in another substance. So next is the entrainment. The low pressure zone induces the flow of another fluid or substance, usually a gas or a vapor, from the surrounding environment into the ejector. Next is the mixing and discharge. The entrained substance mixes with the high-speed fluid and the combined flow is then expelled from the ejector. So next. So here's a video.
The operational principles of jet pumps, also referred to as ejectors, is simple. The pumping effect is achieved using a motive medium, such as a gas flow. This generates a dynamic pressure drop in the motive nozzle. The resulting negative pressure accelerates the suction medium by impulse transmission in the mixing nozzle and pulls it along. Their simple technical design without moving parts makes jet pumps specially robust and low maintenance. The process works with gaseous and liquid media and, depending on the design, is capable of transporting gases, liquids, and even solids. Depending on the specific applications, GEA produces jet pumps from various materials. We use different types of steel, plastic, graphite, and other special materials.
Ah, pabalik po ng isang slide. Yan, yun po. So, for the positive displacements naman po, we have two types. And the first one is the rotary compressors. Next slide po. So for the rotary compressors, they are a type of positive displacement compressor that uses rotating elements to compress gas or air, either rotating blades or impellers to generate kinetic energy to increase the pressure of the gas. Rotary compressors physically reduce the volume of the gas to achieve compression. So sa rotary compressor daw, gumagamit tayo ng parts na nagsispin around like rotating blades or impellers para mag-squeeze ng air or gas inside the compressor para para makompress or mas mapaliit yung air or gas natin dahil pag mas smaller yung gas natin mas magiging stronger yung pressure to achieve compression and ready for different usage which will be explained later. Next slide po. So rotary compressors are preferred for applications where a constant flow of compressed gas is required, as they can provide a steady flow with minimal pulsation. They are also well suited for applications requiring precise control over pressure and flow rates. Additionally, rotary compressors tend to be more energy efficient than dynamic compressors in low to medium pressure applications. So, ayun, kaya naman ginagamit ang rotary compressors in different settings like supermarkets, cold storage facilities, para makompress yung refrigerant gases to extract heat and to enable cooling and ayun, makapag-preserve ng pagkain. Next slide po. We have the types of rotary compressors. First one is the sliding vane compressors. Sliding vane compressors consist of a rotor with slots that hold vanes. The rotor is offset within a cylindrical housing. As the rotor runs, the vanes slide outward due to centrifugal force, creating expanding chambers that draw in gas. As the rotor continues to rotate, the vanes slide back inward, reducing the chamber size and compressing the gas. Next slide po. So, ito po yung picture ng example ng sliding vane compressor and binubuo po ito ng isang rotor na may mga slots na may vane. Yung wala mismo yung rotor sa gitna ng cylindrical housing. So, may habang umiikot yung rotor, yung vane ay nagsa-slide outward na nag-expand yung chambers na kumukuha ng gas. So, every time na umiikot yung rotor at nagsa-slide back inward yung vane, lumiliit yung size ng chamber and nagko-compress nung gas. Next slide po. For the second type naman po, lobe compressors. Lobe compressors are devices used to increase the pressure of air or gas. Lobe compressors feature two or more lobe rotors that rotate within a casing, with the lobes meshing together. As the lobes rotate, air or gas is trapped in the spaces between them and the casing. As the lobes continue to operate, this serves as a compression chamber where air or gas is pressurized. Next slide po. Ayan, yun po yung example ng rotary lobe compressors. So, sa lobe compressor naman po, ayun lang, nagko-consist siya ng two lobes na nagsiserve as their gears para mag-compress nung air or gas. Yung yellow po na part. Next slide po. Another type ay rotary screw compressors. Rotary screw compressors utilize two helical screws or rotors rotating inside a cylindrical housing to compress air or gas. As the screws rotate, the air or gas is trapped in the spaces between the screws and the housing, forming a compression chamber. The volume of this chamber decreases as the screws continue to turn, compressing the air or gas. Finally, the compressed air or gas is discharged through an outlet port. Next slide po. So, ito po, picture ng sample ng rotary screw compressor na may dalawa pong screw and which is also called the rotor. And yung isa pong rotor, tinatawag na male rotor, and yung isa naman po ay female rotor. Kaya din po sila tinawag na male and female kasi match po or fit sila to work and to compress air or gas. Next slide po. Another type is the liquid ring compressor. A liquid ring compressor uses a rotating ring of liquid, typically water, to compress gas or vapor. Inside the compressor, a cylindrical chamber is partially filled with the liquid, forming a rotating ring due to centrifugal force. Gas or vapor is drawn into the compressor, where it is entertained by the rotating liquid ring and compressed as it travels through the chamber. The compressed gas or vapor is then discharged at a higher pressure. Next slide po. So this is an example of liquid ring compressor. So sa loob po ng liquid ring compressor, meron pong isang cylinder na puno ng liquid na madalas po ay yun nga tubig. Tas yung liquid na ito po ay umiikot para mag-create ng parang ring type dahil sa pressure ng centrifugal force. Tas yung sa gas or air naman ay papasok po siya dun sa inlet, dun sa suction. Then habang umiikot yung ring na liquid ay sasabay po yung air dun sa liquid para umikot. Then, yung liquid na ito po ay nagse-serve as sealing medium. So, walang gas na makakatakas sa loob ng compressor. Tas, yun, habang umiikot yung liquid with the gas, ay naiipit ito between the ring and the compressor housing na nagkakos ng pagtaas ng pressure and nako-compress po yung gas. Ayun po. Next slide po. Last type ay yung scroll compressor. A compressor consists of two interleaved scrolls or spiral-shaped components, one fixed and one orbiting, that move in a circular motion. As the orbiting scroll moves, it compresses the refrigerant gas by trapping it in gradually decreasing pockets formed between the scrolls. This compression process occurs without the need of valves, resulting in a smoother and more efficient operation compared to the other compressor types. Next slide po. So this is one example po ng scroll compressor. And dito makikita po natin na may dalawang scroll which is yung fixed and yung isa po ay yung orbiting scroll. Yung fixed scroll nga ay nakakabit sa loob ng compressor housing. Tapos yung orbiting scroll, siya yung umiikot ng circular motion na may connection nga dun sa fixed scroll. Tapos yun, habang umiikot yung orbiting scroll, lumiliit yung spaces between them. Then, yun, nako-compress nila yung gas sa loob. And that's all po for the different types of rotary compressors.
So, under pa rin po ng positive displacement ay yung reciprocating compressors. Next po. So, reciprocating compressors, the term reciprocating refers to the back and forth movement of the compression device. Either a piston or other device is positioned in a cylinder. So, ang keyword lang dyan is yung back and forth movement, which means merong intake stroke and tsaka yung outward stroke, wherein yung sa intake stroke, magdodraw ng gas into the chamber, then sa outward stroke naman ay magdi-discharge ng na-compress na gas. Then, ang idea rin ng reciprocating compressors is yung piston, mag-receive siya ng power or force from the drive shaft and then ita-transfer nito yung power dun sa gas na iko-compress natin. Next po. So, under ng reciprocating compressors naman ay mga piston type compressors. So, piston type compressors are the oldest and the most commonly used compressor in the pneumatic industry because of its flexibility, high pressure capability, ability to rapidly dissipate heat of compression, and oil-free. They are built for either stationary or portable devices. So, ang idea naman dito sa piston type is yung gas. Wait lang. So, yung gas is tina-trap between sa piston and cylinder head and then nako-compress. Then, to further explain po ay, next slide. So, merong two types ng piston type. Ang single acting and the double acting compressor. So, sa single acting, only one side lang ng cylinder kino-compress yung gas. Whereas sa double acting ay sa outward stroke and sa downward stroke kino-compress or yung compression ay nangyayari. Next po. So here naman is yung mga working equation for single acting compressors. So we are already familiar since na-discuss na naman to sa ating fluid machinery. So for PVT relation, so P1V1K is equal to P2V2K and so on. Then yung piston displacement naman ay pi over 4 d squared ln times nc times np or yung cylinder times yung piston actions. So yung this explains lang na yung piston displacement natin is nakadepend sa diameter, sa length ng piston stroke at sa number ng cylinders and also yung speed ng rotation ng ating crankshaft. For piston speed naman, V is equal to Ln. Then, volumetric efficiency is yung ratio ng actual volume natin and sa theoretical volume. And other formula naman is yung 1 plus C minus C quantity P2 over V1 raised to 1 over K. So, ayan naman ay na-encounter na rin sa refrigeration system. So, yung C nga pala is yung clearance volume. So, for common knowledge naman, since naturo na rin, ay yung ang clearance volume, 'di ba, merong piston. Then na-reach na yung TDC or yung top dead center ng cylinder. However, merong area na hindi natatouch ng piston dun sa cylinder since meron lang limited or certain length lang na naaabot ng ating piston. And yung small volume na yun na hindi naaabot, ang tawag dun is yung clearance volume. Next po. So, here naman is yung sa double acting. So, ang pinagkaiba lang niya is either na-neglect yung rod and nako-consider. So, dun sa rod neglected, parang kaparehas lang siya ng sa single acting, however, naka times 2. Then, for rod considered naman is may additional pa na pina-plus aside from dun sa typical natin na formula. Next po. So, here naman yung diagram for piston type compressor. So, ang working principle lang niya is merong reciprocating piston or gumagamit siya ng piston in order to compress yung gas sa ating cylinder. So, yung piston natin is driven by the electric motor. So, yun yung nagpo-provide ng reciprocating motion sa ating piston. And sinisealed siya gamit yung suction chamber and the discharge chamber, which nagko-control siya ng in and out ng flow ng ating gas sa cylinder. So, pag nag-move yung piston natin pababa, so mag-create siya ng vacuum sa cylinder which draw in yung gas from the inlet valve. Then, pag nag-move up naman yung ating piston, mako-compress yung gas and magkakaroon ng pressure. So, pag tumaas yung pressure, mag-open yung outlet valve natin and yung compressed gas natin is lalabas ng cylinder. Next po. Another type po ng under reciprocating compressor ay yung diaphragm. So, ang idea lang dito, gumagamit siya ng flexible diaphragm to compress gas. And yung diaphragm natin is made out of flexible materials such as plastic or rubber. Then, ang application niya is for pharmaceuticals, medical, and laboratory. So, yung diaphragm natin, siya kasi yung parang act as barrier para hindi makontaminate yung ating um, yung ating gas from the contamination from sa ating drive mechanism. So kaya applicable siya sa mga pharmaceuticals kasi yung gas purity dito ay critical. Next po. So here yung diagram for diaphragm type. So yung diaphragm natin, dinidivide yung cylinder natin into two side. Ang first side is yung side ng taas, yung discharge port and the suction port, and yung other side naman is yung connected sa drive mechanism. Um, so dun sa suction stroke, okay, of course, suction, so nag-i-intake ng air. So yung compensating pump, nagde-deliver ng oil, low quantity of oil through the check valve papunta dun sa oil head. Then yung piston ring nagli-leak and yung membrane approach the oil head so that yung air is makakapasok. For delivery stroke naman, of course, compression of air happens and dito nag increase na yung quantity ng oil para ma-lift yung membrane towards dun sa gas para ma-reduce yung space ng air. So, 'pag nag-increase na yung pressure dito or yung pressure sa loob is mas mataas kaysa sa pressure sa labas, yung valve is nag-o-open and yung compressed gas is ma-release and the process continues lang. Next po. So, yung difference lang natin for piston and diaphragm. So, 'pag piston, gumagamit ng reciprocating piston, sa diaphragm naman gumagamit ng flexible diaphragm. Then sa piston naman, puwede niyang ma-contaminate or basta puwedeng, contamination may happen. Sa diaphragm naman since meron nga siyang parang sealing pine-prevent niya yung leakage, so contamination free and oil free siya. Then for piston naman, required ang lubrication. Sa diaphragm naman, less maintenance kasi hindi naman kailangan ng lubrication or hindi nag-come in contact yung gas, dun sa ating drive mechanism. However lang, nagwe-wear over time ang ating diaphragm kaya need niya air replace periodically. Next po. So, other type is yung trunk natin. So, this type of compressor has a single acting cylinder and is limited to refrigeration service and to smaller air compressors. So, dito naman, directly connected ang ating piston dun sa ating connecting rod. So, limitation ng rotational speed are less restricted, kaya inaalaw niya yung higher speed. Then, next po. For crosshead naman, yung piston is driven by a fixed piston rod that passes through a stuffing or packing box and is connected to a crosshead. The crosshead in turn is connected to the crankshaft by a connecting rod. So kung kanina sa trunk, directly connected ang piston sa piston rod or sa connecting rod, dito sa crosshead ay may isang component which is yung crosshead na nagli-link sa piston and the connecting rod. Next po. So, yan yung diagram for trunk and crosshead. So, makikita naman dun sa right side, nagka-run lang ng crosshead dun sa crosshead compressor. So, ang idea kasi ng crosshead, siya yung nag-guide sa piston movement ng cylinder instead instead of depending lang dun sa piston skirt to do the guiding. So, dito, inaalaw niya yung piston na less parang yung ratio ng less to diameter ratio is, pinapababa niya. Then pine-permit din niya yung longer stroke and greater capacity. Also, pino-provide din ng crosshead sa compressor yung greater stability para provide lang ng less vibration and less piston ring and wear and tear, thus allowing yung double acting design instead dun sa trunk na single acting lang. Next po. So for labyrinth naman, so makikita yung diagram. So dito, merong additional or unique technology na ini-employ. So makikita dun sa right side wherein yung naka-circular. So between the piston and the cylinder wall and between sa piston rod at saka dun sa piston sealing gland, merong labyrinth seal. So, ang idea lang nito is ng labyrinth seal is, of course, may sealing effect and made up of tiny throttling points lang siya which resist yung leakage from high pressure to low pressure. So, dinidesign siya for airtight construction with the labyrinth effect or yung mga gas na completely dried condition. So, most suited siya for handling gases na completely dried such as N2 or yung combustible gases liable to be ignited by heat created by friction which is dun sa O2 and other gases pa na liable to be mixed with mist, dust, and others. Yun lang po.
And for our operating principles, compressors are used in a variety of industries and have many uses. They are designed and selected based on inlet pressure, gas flow, and final discharge pressure. Inside the compressor, mechanical components compress gases and vapors for use in a compressor system. So, familiar na naman tayo sa mga compressor. And halos lagi na natin 'to nakikita lalo na sa mga driver, tulad nga ng sinabi kanina ni Master Dieter, once na once na na-flat natin yung mga gulong para mas mapadaling hanginan yung mga gulong, is gagamitan natin ito ng air compressor. And when selecting compressor, unit designers must take into consideration the capability of the compressor and the process condition. Siyempre, kapag ka naman gagamit tayo ng air compressor, dapat alam natin yung capability nito. Hindi naman, halimbawa, kapag ka maghahangin lang tayo ng gulong ng bisikleta, alangan naman ang gamitin natin is yung malaking compressor. Siyempre, dapat alam natin yung capability nito para makaiwas tayo sa disgrasya, sa failure. Single stage versus multi-stage compressor. So, una muna is the single stage compressor. Single stage reciprocating compressor, all the compression process takes place in only one cylinder. Two valves connect with the cylinder. One is an inlet or suction valve, and the other is an outlet or delivery valve. The opening and closing of a spring or plate valve vary on the pressure difference. When mechanical valves used for suction and discharge, their function controls through pumps. So dito sa single stage compressor na ulit na naman kanina ni Master Dian yung process ng ating piston dito sa single stage compressor. So once nga na yung piston natin is nag-slide na pababa galing sa TDC or the top dead center, mag-o-open na yung ating inlet valve and papasok na dito yung gases. And once na may gases na dito sa ating cylinder, mag-slide na pataas yung ating piston and nagko-compress na itong gases into high pressure and high temperature. Pag na-compress nyo na ito, lalabas na to sa ating outlet valve. And sa outlet valve is nakakonekta ito sa ating storage tank. And yun, paulit-ulit lang yung process hanggang sa mapuno na yung ating storage tank. And sa single stage compressor, kumbaga limitado lang yung mga gamit na pwedeng paggamitan ng ating single stage compressor. Maaaring sa mga pagkahangin nga lang ng mga gulong, pagpipintura, pwede din gamitin sa pagkakalas ng mga tornilyo. And yun yung process sa ating single stage compressor. Compare naman natin sa ating multi-stage compressor. Multi-stage compressor compress the gas multiple times by delivering the discharge from one stage to the suction inlet or another stage. Multi-stage compressor raise the gas to the desired pressure in steps or stages or the chambers. Cooling the gas between each stage. Between stages, the gas from a multi-stage compressor is cooled. During this cooling phase, liquids are frequently condensed. So bukod sa tatlong piston cylinder tong ating multi-stage compare sa single stage, ang pinagkaiba pa ng multi-stage ay meron itong cooling process or meron itong intercooler na once na sa first stage, kapagka nakapag-compress na dito ng gas into high pressure and high temperature, bago sa lumipat sa second stage is dadaan muna sa intercooler para ma-maintain yung high temperature and high pressure. Then after sa second stage, daan muna uli sa intercooler, and after naman sa third stage, diretso na ito sa storage tanks. And ang purpose nga ng ating cooling process is ma-maintain yung init para hindi nga masira itong ating compressor. Kasi pagka sobra na yung init na pumunta dito sa ating third stage is baka mag-failure na 'tong compressor natin. And multi-stage compressor can be centrifugal, axial, or reciprocating piston compressor. And centrifugal compressor performance curve. And para mas lalo nating maunawaan 'tong pagmo-monitor sa ating performance curve is dito.
Pressure, temperature, compressibility, molecular weight, and specific heat ratio of the gas at the compressor inlet and the machine's rotational speed affect the operating performance of centrifugal compressors. For example, a compressor receiving inlet air at atmospheric conditions will develop higher discharge pressure on cold days than on hot days at a given rotational speed and inlet volume flow. The power requirement also will be higher. Changes in atmospheric conditions such as relative humidity and barometric pressure will affect performance, although these factors are usually less significant than inlet temperature. We can account for these changes and others encountered during operation by modifying the performance curve of the compressor. Manufacturers of centrifugal compressors often supply curves that define the machine's aerodynamic performance. These curves take many forms, some of which are polytropic or adiabatic head versus inlet volume flow as seen here, or discharge pressure versus inlet volume flow. The data for the performance curve are the nameplate rating conditions. So, inlet pressure, inlet temperature, molecular weight, ratio of specific heats, and inlet compressibility. The manufacturer will not normally supply performance curves for other than rated inlet conditions unless specifically requested. In this section, we will develop application procedures for modifications to the performance curve for a single-stage centrifugal air compressor. Of course, these procedures are valid for any gases and for multi-stage centrifugal compressors with somewhat reduced accuracy as the number of stages increases.
So ang purpose nga ng ating pag-track ng performance curve is para ma-monitor ng ating mga kalimitan mga engineer yung kung may problema ba yung ating compressor para malaman kung may singaw ba yung mga piston, kung may crack ba yung ating cylinder, and para matrack nga kung kailangan na bang palitan or kailangan na bang ayusin yung ating mga compressor. Yun yung purpose ng pagmo-monitor sa performance curve.
Yes po. In a single crank, single acting compressor, the low pressure and high pressure pistons are connected in tandem to a single crank. In low pressure stage, when the piston moves down, the atmospheric air is inducted. The compressor air from the first stage flows to the second stage through the intercooler. The pressurized air is inducted into the second stage. As the piston moves up, compression takes place in both stages. The high pressure air from the second stage is delivered through the aftercooler. In a single acting, two crank compressors, the low pressure and high pressure pistons are connected to two separate cranks. As the low pressure piston moves down, air is inducted through the air filter. When it moves up, the air is compressed and delivered to the second stage through the intercooler. The air is further compressed in the second stage and high pressure air is delivered through the aftercooler. In a double acting compressor, compression takes place during the upward as well the downward stroke of the piston. In this arrangement, the low pressure first stage piston is at the top and the high pressure piston is at the bottom. In the first stage, as the piston moves up, air is compressed and the compressed air is inducted into the second stage. When the piston moves down, the pressurized air is further compressed in the second stage. In the meantime, the low pressure stage inducts fresh air from atmosphere through an air filter. In this way, the process is cyclical. In three-stage compression, the air is inducted at the first stage, compressed, cooled by the intercooler, and delivered to the second stage. In the second stage, the air is compressed further and delivered to the third stage. In the third stage, air is compressed to the required pressure and delivered through an aftercooler. When the piston moves up, air is compressed in the first and third stages, whereas air from the first stage is inducted into the second stage.
Welcome to BITSA. Welcome to the heart of freshness. I will describe how the OAHC oil separator works. The newly developed horizontal oil separator is ideal for use with ammonia screw compressors. The innovative design of the combined oil separator uses 3 separation stages in order to dramatically reduce oil carryover in ammonia refrigeration systems. Refrigeration oil is primarily separated in the first separation stage, thanks to centrifugal and gravity principles, which ensure the maximum performance at both nominal and partial load. A second separation action then takes place in the demister section. Finally, a group of highly efficient coalescent filters provides the last step of oil separation. Thanks to multi-step separation, the oil separator ensures outstanding separation efficiency. With a tested final oil carryover rate below 10 ppm, the oil separator ensures optimal compressor operation and minimum oil consumption. Optimized oil charge amounts and a service flange for simple filter replacement round off the benefits of the OAHC oil separator. Thanks for watching this video, and I hope you watch some of our other videos. Thank you.
So, done na po sa presentation. Let's proceed naman po sa pa-quiz ng aming group. Next. So, kuha lang po ng clean sheet of paper. Then, isa-send po sa GC ang sagot nyo po.
Sabi na lang po kung ready na po.
Pa-raise na lang po ng hand if tapos na po sa slide. Thank you.
Pa-raise hand na lang po if tapos na po. Tapos na po ba ang lahat?
So once done na po ay pa-picture na lang po ng inyong paper and kindly send sa GC. And that is all for our presentation po. Thank you.
Okay, thank you so much, Group 7. Job well done. So, we are going to proceed with the last group, para tayo makausad na. So, Group 8, Heat Exchangers, you may proceed now with your presentation.
Good afternoon po everyone. Tayo po ay dadako na sa last topic sa ating manual which is ang heat exchangers. Next slide po. Alright. What is a heat exchanger? A heat exchanger is a device designed to facilitate the transfer of thermal energy between two or more fluids at different temperatures without the fluids coming into direct contact. This process occurs through conduction, convection, or radiation depending on the design and operating conditions of the heat exchanger. Meaning po, ang heat exchanger ay nag-a-act as a mediator between two different fluids na may magkaibang temperature. Ang job po ng ating heat exchanger ay makapag-transfer ng heat from the hotter fluid to the colder fluid without the two fluids mixing together. Nagagawa po ito ng ating heat exchanger by having a barrier between the two fluids, which is it can either be solid wall po or solid surfaces. Whereas do sa solid wall po at sa solid surfaces ay kaya pa rin po mag-transfer ng ating heat. So, ibig sabihin po, if one fluid is hotter than the other fluid, the heat exchanger will allow the heat from the hotter fluid to flow towards the colder fluid, making the colder fluid warmer and the hotter fluid a bit cooler. So, ibig sabihin po, nag-a-act po ang ating heat exchanger na as a bridge para mag-flow po yung ating heat from the hotter region towards the colder region. Next po. And purpose of heat exchanger. Let's start po sa purpose ng ating heat exchanger, which is under po nito ay ang temperature control, energy efficiency, heat recovery, condensation and evaporation, space heating and cooling. Sa temperature control po, ang ating heat exchanger ay ang mamahala sa temperature regulation sa isang process. It can either be in industrial processes or kahit ano pa pong process or system na gumagamit ng heat exchangers. Ang pinakatrabaho po ng heat exchangers sa temperature control ay para ma-reach po, ma-ensure po ang optimal operating conditions at ma-maintain po ang product quality sa isang system or isang engine. Next naman po ay sa energy efficiency. Sa energy efficiency naman po, ang ating heat exchanger ay nagre-recuperate ng mga wasted heat mula sa ating exhaust streams or hot fluids na itinatransfer sa ating colder fluids, which is ang heat exchanger po ay nagko-contribute sa energy conservation o kaya naman po ay pag-i-improve ng efficiency ng ating system o kaya naman po ay machines. Next is heat recovery po. Kagaya rin po na na-mention sa ating energy efficiency po, ito po yung pagre-recuperate po ng wasted heat kung saan po ay nare-recover natin yung thermal energy from the outgoing streams ng ating systems, kung saan nare-reduce po nito or nakaka-help po to ma-reduce ang energy consumption at saka operating costs ng isang system. Next naman po ay ang popular na po sa lahat na condensation and evaporation na madalas po nating maririnig pagdating sa ating refrigeration systems o kaya naman po ay air conditioning system, which is nagpe-play po siya ng critical role in maintaining the desired environmental conditions sa isang refrigeration system o kaya naman po ay air conditioning system, which is ito po yung process ng pagkondensate po ng vapor into liquid o kaya naman po ay evaporation from liquid into vapor. Next naman po is space heating and cooling, which is mainly applied sa mga residential or commercial buildings. Yung heat exchanger po ay integral components po, lalo na po sa ating HVAC system na nag-enable po ng efficient heating at cooling exchange between sa mga airstreams po sa mga commercial buildings. Next naman po is application po ng heat exchanger. We have various application po which is involves chemical industry, power generation, oil and gas, food and beverage, automotive, and especially HVAC systems. Sa chemical industry po, ang ating heat exchanger ay madalas na-utilize sa mga chemical processes na nag-i-involve po ng heating, cooling, condensing, and evaporating fluid sa mga reactors, distillation columns, o kaya naman po sa other unit operations sa ating chemical industry. Next naman po ay sa power generation, which is mainly employed po ang ating heat exchanger sa steam generation, turbine cooling, and heat recovery systems na nag-optimize sa mga thermal efficiency and reducing yung environmental impact po ng power generation. And third po ay oil and gas, which is mainly applied sa ating pagre-refine po ng mga oil o kaya naman po ay pagpaprocess ng ating mga crude oil. Next ay food and beverage, which is ang heat exchanger po ay popular sa mga processes tulad po ng pasteurization at saka sterilization and thermal processing ng mga beverages o kaya naman ng mga packaged foods. Next ay automotive po. So application po ng heat exchanger sa ating mga sasakyan or sa makina ng ating mga sasakyan, which is siya po yung nag-a-act as cooling system or nagpa-facilitate ng heat dissipation para para mas maging efficient pa rin po ang operation ng makina ng bawat sasakyan. Next is HVAC system, which is ang heat exchanger po ay yung pinaka-essential po pagdating sa ating heating, ventilation, and air conditioning systems para sa mga indoor climate control o kaya naman po energy recovery o kaya humidity regulation sa isang residential or commercial or institutional buildings. Next naman po ay ang ating type of heat exchangers. Next slide po. Type of heat exchangers according to their flow configuration. Meron po tayo dito ang concurrent or parallel flow and countercurrent or counterflow and single pass cross flow and multi-pass cross flow or multi-stream cross flow. Ang concurrent or parallel flow naman po, next slide, ay according based po dito sa nakikita nyong illustration ay nagpo-flow po ang ating hotter liquid at colder liquid at the same direction. Kung saan po ang ating heat transfer ay nagaganap as long as the two liquid flow along together. Next naman po ay ang ating counterflow, which is completely opposite naman po ng ating parallel flow. Kung saan nakikita nyo po sa ating illustration na ang ating hotter liquid po ay nagpo-flow indirectly dun sa flow po ng ating colder liquid. Kung saan naman po ay mas napapataas po nito ang heat transfer efficiency ng ating heat exchanger kasi mas na-maximize po nito ang temperature difference po between sa ating colder fluid from our hotter liquid. Next naman po ay ang cross flow. Single pass cross flow, which is kung makikita nyo po rito ay ang ating colder fluid ay nagpo-flow perpendicularly sa ating hotter liquid, which is mainly one fluid ay nagpo-flow across usually through pipes or channels kung saan ang arrangements ay like one river flowing over a bridge that the other river runs under. Next naman po ay multi-stream flow or multi-pass cross flow. Sa isang multi-stream flow po, there are multiple streams. Kumbaga po ay iba't iba po ang makikita natin na flow configuration dito. Maaaring andito po lahat yung nabanggit kanina, which is yung parallel flow, counter flow, o kaya naman po yung single pass cross flow. So ito lang po ay parang incorporation ng unang tatlong cross flow ng unang tatlong flow configuration po ng ating heat exchanger sa isang device. Next po ay ang ating relative heat transfer surface area and temperature rise diagram. So dito po makikita natin ay ang area at saka yung rate po ng heat transfer. Dun po sa parallel flow, makikita po natin na ang required heat transfer area po niya ay mataas, while yung kanya naman pong heat transfer rate ay mababa. Which is, next naman po ay ang ating counter flow, which is nagre-require din po siya ng higher heat transfer surface area. Pero mas mataas naman po ang kanyang rate of heat transfer kaysa dun sa ating parallel flow. And next naman po ay ang cross flow. Kung makikita po natin sa diagram, ang kanya pong required heat transfer surface area ay mas less or mas mababa sa ating parallel flow at saka sa cross flow kasi ang ating pong cross flow ay mas ginagamit po sa mas maliliit na application. Pero mas mataas naman po ang kanyang heat transfer ratio. Next po.
Classification according to transfer processes. Heat exchanger are classified according to transfer process into indirect contact type heat exchanger and direct contact type heat exchanger. Next po. Ang indirect contact heat exchanger operates by keeping the fluid stream separate while facilitating heat transfer through an impervious dividing wall or by transferring heat into and out of a wall in a transient manner. This means that the fluids involved never directly come into contact with each other during the heat exchange process. Bale, ang tatandaan lang dito, separate fluid streams. Ang fluid ay segregated through the process. Hindi nagkakaroon ng direct contact ang two fluids sa heat exchange process. Tapos, impervious dividing wall, ito ay barrier na nag-aalaw sa heat to pass from one fluid to other na hindi sila nagmi-mix. Tapos, transient heat transfer. In some cases, the heat transfer might occur into and out of the wall in a transient manner. This means that the heat is absorbed or released by the walls, which then transfer it to the other fluid without direct contact between the fluids. Next po. Ang sumunod naman ay direct contact type. Dito naman, ang two fluids ay nagda-directly touch each other to exchange heat. They are often used in processes like evaporation or cooling, where changing from liquid to gas or vice versa. Ang mga exchangers na ito ay nagtatransfer ng heat ng mas mabilis at hindi masyado expensive i-build. Pero since ang dalawang fluids ay nagda-directly touch, ito ay magagamit lang sa mga pwedeng gamitin na sitwasyon. Next po. Sinasabi lang dito na ang classification according to process function, categorized heat exchanger ay naka-base sa specific roles in the thermal process kung saan ang condenser ay pang-convert ng vapor to liquid, heaters for increasing fluid temperature, coolers for reducing fluid temperature, and chillers for precise and low temperature cooling application. The condenser ay ang starting point where vapor is turned back into liquid. There are two main ways this to happen. Yun ay ang direct contact at ang indirect contact. Sa direct contact condenser, they are vapor and the cooling medium touch directly. There are different types like pool, spray, tray, and pack column. Sa indirect condenser naman, the vapor and the cooling medium don't touch directly. Instead, they exchange heat indirectly. The main types are shell and tube, extended surface, and plate type. Sa shell and tube condenser are mainly used in both power plants and industrial processes. Extended surface condenser includes special design like tube fin air-cooled and plain fin cryogenic. Plate type condenser come in plate and spiral configuration. These condensers are used in different industries for cooling and turning vapor into liquid. In the power industries, you find surface condenser for power plants and feed water heaters to reuse steam. In the process industry, total condensation is a process where all vapor turns into liquid. Reflux and knockback are specific step in this process. Tapos ang liquid to vapor phase change exchanger like boilers and vaporizing exchanger transform liquid into vapor using heat. Boiler use combustion while vaporizing exchanger rely on external heat sources. Steam generators are a common example using heat from reactors to produce steam. Waste heat boilers capture industrial waste heat for steam production. Evaporators remove water as vapor used in power plant and chemical processes, including power plant and chemical evaporators. Reboilers and vaporizers are also for heating liquid in processes like distillation. In short, itong mga exchanger na ito ay mahalaga para sa power generation, chemical processing and manufacturing for steam production, waste heat recovery, and chemical processes. Next po. Classification of heat exchanger by construction type. Heat exchanger can also be classified according to their construction features. For example, are tubular, plate fin, tube fin, and regenerative exchanger. Next po. Sa tubular heat exchanger, these heat exchanger are versatile and typically use circular tubes, but other shapes like elliptical or rectangular tubes can also be used. Ang design can be easily adjusted by changing tube size and layout. They are excellent for handling high pressure and temperature difference between fluid. Next po.
Shell and tube heat exchangers will look something like this. With this design, we normally for the heat exchanger known as the header. Then we have another inlet and outlet for fluid 2 on the main body known as the shell. Inside the unit we have the tubes. These bend and loop around to start and finish at the tube plate, which sits between the shell and the header. The tubes will usually also pass through some baffles, which are sheets of metal. We will see how these work in just a moment. The header, as well as the tubes, can be removed for cleaning, repairs, and maintenance. Inside the header is a sheet of metal known as the divider, or the partition. This separates the tube ends, enabling the fluid to flow into and then out of the heat exchanger tubes. Fluid 1 will flow through the header, into and around the tubes, then back to the header. Fluid 2 will enter the shell and surround the outside of the tubes. The baffles will partially block the flow, which will force the fluid to turn multiple times. This creates a turbulent flow and ensures that fluid 2 mixes with itself, which ensures maximum heat transfer. For example, we might find this in a pharmaceutical factory with a boiler providing steam into the shell, which surrounds the tubes. A chemical product is then pumped through the tubes, and this absorbs the heat of the steam through the tube wall. So this product is going to exit the heat exchanger much warmer. Meanwhile, the steam will start to condense into a liquid and flow back to the boiler to pick up more heat and repeat the cycle. Additionally, these are used in refrigeration applications, like this industrial chiller. We have the water flowing through the tubes, and the hot refrigerant in the shell. The water will absorb the heat of the refrigerant so that it can transport this to the cooling tower, where it will be ejected into the atmosphere. The water returns cooler to pick up more unwanted thermal energy from the chiller.
Bale, yung video na pong yan ay nagpapakita kung paano nagwo-work ang isang shell tube heat exchanger. Next po. Sa plate heat exchanger naman, ito ay gumagamit ng thin plates, either smooth or corrugated, arranged flat or wood in a coil. They are efficient and compact but have limits in handling high pressure or temperature differences. There are gasketed, welded, and brace type, each with different leak tightness level. Gasketed ones have flexible seal and easy for cleaning. Welded ones are durable for higher pressure, and brace ones have strong bonds between plates. Other types include spiral plate, lamella, and plate coil na meron silang kanya-kanyang advantages. Next po.
Yan po. Another type po is the plate fin heat exchanger. Ito po ay device used to transfer heat between two fluids and consists of alternating layers of flat plates and corrugated fins, providing a large surface area for heat transfer. The fluid flow in separate channels formed by the plates and fins, with the heat transferred between them through the walls of the plate. The plate fin heat exchangers are favored for their high efficiency and compact design, making them suitable for various applications like aerospace, automotive, and HVAC systems. And ang working principle naman po niya, there is two fluid flow streams, typically yung hot and cold fluid po, and it will enter our heat exchanger through separate channels. And heat is transferred between fluids through yun nga po, yung thin fins and connected plates. And the large surface area of the fins po facilitates efficient heat transfer. And the plate fin heat exchangers often use counterflow arrangement in which the hot and cold fluids flows in the opposite direction. And sabi nga po, ang arrangement po ito ay nagbibigay ng higher efficiency ng ating heat transfer. And next po. Ang next po is our tube fin heat exchangers. A tube fin heat exchangers is a type of heat exchanger where tubes with external fins attached to them are used to transfer heat between fluids. One fluid flows inside the tube while the other flows outside. With the fins, increase the surface area for heat exchange. These heat exchangers are widely used in applications requiring efficient heat transfer in compact design such as air conditioning, refrigeration, and industrial process. And yung working principle naman po niya, parang similar lang din po sa plate fin heat exchangers where two fluid flows enter the heat exchanger through the separate channels, the hot and the cold po, and heat is transferred from the fluid inside the tubes to the fluid outside through conduction. And these fins attached to the tubes increase the surface area available for heat exchange, allowing for the efficient heat transfer for thermal energy between two fluids. And sabi po, tube fin heat exchangers are more efficient than plate fin heat exchangers. And next po is our printed circuit heat exchangers. A printed circuit heat exchanger is a compact and efficient heat exchanger designed inspired by the technology used in the printed circuit boards. It consists of multiple layers of thin metal plates with fluid channel etched or stamped into them. These channels are designed to optimize heat transfer between the fluids while maintaining a compact form factor. And then yung working principle naman po niya, ang printed circuit heat exchanger is design niya po based sa concept ng microchannels and edge flow paths. Similar po dun sa mga electronic printed circuit board and typically consist of multiple layers of thin metal plates as you can see po sa ating illustration where with intricate fluid channels etched or stamped to them. Yung channels po ito is designed to optimize heat transfer between two fluids by maximizing surface area contact and minimizing thermal resistance. And heat transfer occurs as the fluid flows through the channels within this printed circuit board. The close proximity of fluids within the microchannels enhances the convective heat transfer between them, allowing efficient thermal energy exchange. And then po, yung mga printed circuit boards po natin is commonly used in aerospace, automotive, and chemical processing industry po. And last is the regenerative heat exchanger. It is a type of heat exchanger that uses a matrix or bed of material with high heat capacity to transfer heat between two fluid streams. It operates in cycles with one fluid stream passing through a matrix absorbing heat while the other fluid stream passes through and release heat in the matrix. Then in the next cycle, the roles of the fluid are reversed. This allow for the efficient heat exchange between two streams with the minimal temperature difference. Yun po, sabi po, yung one fluid po will pass through a matrix, as you can see po dito, absorbing heat and increasing temperature, while yung other stream po flows in the opposite direction, release heat, releasing heat to the matrix and cooling it down. The heat transfer process occurs in cycles and typically in a counterflow arrangement. Then the roles of the fluid streams are reversed, allowing for the efficient heat exchange with minimal temperature difference between the stream. Ang application naman po niya is it is used where energy efficiency and heat recovery are critical, such in industrial processes, power generation, and HVAC systems.
Let's proceed naman po sa heat exchanger applications. Heat exchangers play a crucial role in various industries and applications including HVAC systems like sa mga air conditioner or heater sa bahay. Nakakatulong po ang heat exchangers in making the air warmer or cooler by moving heat around, then pati sa radiators on internal combustion engines, yung parang grill-like things po sa mga unahan ng kotse. Yun po yung radiator na nagfa-function as heat exchanger na nakakatulong naman para ma-cool ang engine by getting rid of the heat produced kapag umaandar. And sa boilers naman po ay tinatransfer po ng heat exchangers ang heat from combustion gases to water para mag-produce ng steam. And for condensers, kadalasan ginagamit sa refrigeration and air conditioning systems and nagfa-facilitate ng transfer of heat para ma-condense into a liquid state. And for preheaters and coolers, para mas mapabilis naman ang process at ma-improve ang efficiency. But for this application po, ang itatakal po namin na itong apat. Yung preheater, radiator, air conditioner, evaporator, and condenser, and also the large steam system condensers. Next po. For application po sa preheater, bali ang preheater po in a heat exchanger is a stage or component within the heat exchange system responsible para mapataas ang temperature ng fluid bago ito pumasok sa primary heat exchange process. In simple terms, para po siyang warm-up stage for the fluid to increase the temperature at ma-prepare for more efficient heat exchange within the main part of the heat exchanger. Ina-ensure po sa stage na ito na nasa appropriate temperature ang fluid bago pumasok sa main heat exchange section ng system to help optimize the performance. Sa mga large systems or any process na kailangan po ng high temperature, common practice po na mag-preheat muna in stages ng fluid for more efficient transfer of energy from the heat source to the fluid being heated. For example po, dito po sa YouTube feed water heat exchanger, which is a type of heat exchanger na kadalasan pong ginagamit sa mga steam power plants or industrial boiler, and also classified as a preheater, ang function po nito ay ma-preheat muna yung feed water bago pumasok ng boiler from ambient temperature to required boiler temperature. Ang process po nito ay bali yung steam ay papasok sa top ng heat exchanger surrounding the tubes, and habang dumadaloy po yung steam around the tubes guided by baffles para sa path ng flow na parang pa-curve po, ita-transfer ni steam ang thermal energy to the cooler tubes para ma-condense into liquid water. And yung process po ito ay nagre-release ng latent heat of vaporization, further heating the tubes. Yung condensed steam po na liquid form na ay lalabas naman po siya sa heat exchanger doon po sa baba. And sa pagpasok naman po ng feed water sa heat exchanger doon po sa bottom right end, mas na-expose po agad si feed water sa mababang temperature since most tubes are submerged below the fluid level on the shell side. Kaya magfa-flow po si feed water through tubes, absorbing heat from the surrounding condensed steam at unti-unti po siyang iinit. And after passing through the tubes, yung partially heated feed water po ay magfa-flow ng 180 degrees na para pong U-turn. And dito po sa pag-flow niya, ay may encounter na niya yung hotter steam na pumapasok sa shell side ng heat exchanger. Dito mag-a-absorb ng additional thermal energy ang feed water from the hotter steam surrounding the tubes, and finally, yung fully heated feed water ay lalabas na ng exchanger from the top right end. And para po mas maiintindihan pa ay papakita ko lang po yung flow ng fluid dito sa YouTube heat exchanger para maintindihan yung preheating na nagaganap sa feed water. Next slide. And bali po yung color red ay yung flow ng steam guided po ng baffles para sa direction or path ng fluid na parang pa-curve. And yung blue naman ay yung flow po ng feed water na nagbe-bend ng 180 degrees or parang U-turn nga para mapainit po yung feed water bago pumasok siya sa boiler. And dito po sa YouTube feed water heat exchanger, na-achieve po yung preheating gamit po yung init na galing sa steam para mapainit muna si feed water bago ito pumasok ng boiler. And inaalaw po ng YouTube ang feed water para mag-flow through one side of the heat exchanger habang ang steam naman po ay nagpa-flow through the other side, transferring heat from the steam to the feed water. And this preheating process helps to improve the efficiency ng boiler by reducing the amount of fuel needed to heat the water to its operating temperature. Additionally, preheating the feed water helps to reduce thermal shock to the boiler components na kung saan nakakapag-extend pa po ng life ng equipment. Next slide. Next slide. Next slide po. Nasa radiator na po ba? The slide? Lalag lang pala. For the next application naman po ay para sa radiator. Ang radiator po bale ay isang type ng heat exchanger na kadalasang ginagamit sa mga cooling systems to transfer heat from a hot fluid to the surrounding air. In vehicles such as cars or trucks, yung radiator po ang vital component ng cooling system responsible for dissipating heat generated by the engine. Yung process po dito sa radiator, bale meron siyang hot coolant na galing po sa engine and dadaloy po siya sa radiator through inlet pipes. And this coolant absorb heat mula po sa engine na kailangang mag-cool down. And inside po sa radiator, magfo-flow na yung hot coolant through a series of narrow tubes habang yung air naman na ang dadaloy sa exterior ng tubes either nagaling sa motion ng vehicle or sa help ng fan. And habang pong nagsisirculate yung hot coolant sa tubes, matatransfer ang heat mula sa coolant papunta sa metal ng tubes. And yung airflow po na nagpapas sa tubes ay absorb ang init na nagkakos sa coolant para mag-cool down. And kadalasan pong meron ditong thin metal fins and radiators na naka-attach outside the tubes. And these fins increase the surface area of the radiator, facilitating more efficient heat transfer between po dun sa coolant at sa air. And after pong ma-release na yung heat dun sa radiator, yung cooled na coolant po ay lalabas na through outlet pipes and babalik po siya sa engine para mag-absorb ulit ng heat at dun po makukompleto yung cooling cycle.
Next application naman po is air conditioner, evaporator, and condenser. All air conditioning system contains at least two heat exchangers, usually called the evaporator and condenser. Evaporator or condenser. The refrigerant flows into the heat exchanger and transfer heat, either gaining or releasing it to the cooling medium. These two, the evaporator and condenser, are essential components of an air conditioning system, each playing a distinct role in the cooling process. Next slide po. The evaporator is located inside the indoor unit of an air conditioner. It absorbs heat from indoor air as the refrigerant passes through it, cooling the air down. This cooled air is then circulated back into the room, contributing to a more comfortable indoor environment. In contrast, the condenser is situated in the outdoor unit of an air conditioning system. Its primary function is to release the heat absorbed by the evaporator coil as the refrigerant flows through the condenser coil. It expels the absorbed heat to the outdoor air, causing the refrigerant to condense back into a liquid form. In summary po, the evaporator absorbs heat from indoor air to cool it down, while the condenser releases this absorbed heat to the outdoor environment, working together to maintain a comfortable temperature indoors. Next slide po. Dito po ay makikita po natin ang diagram po ng refrigeration cycle. The refrigeration cycle starts with the compressor pressurizing the refrigerant gas, which then moves through the condenser to release heat and condense into a liquid. The expansion valve regulates the flow of fluid refrigerant into the evaporator, where it absorbs heat from indoor air and evaporates back into a gas. This continuous cycle of compression, condensation, expansion, and evaporation help maintains a comfortable indoor temperature by transferring heat effectively within an air conditioning system. Next slide po. The choice of cooling medium for the evaporator and condenser in air conditioning system can vary between air and water based on specific system requirements. The evaporator in an air conditioning system absorbs heat from the indoor air. For conditioning application, two common types of evaporators are used, air-cooled and water-cooled. An air-cooled evaporator typically consists of copper or steel pipes with aluminum fins, while a water-cooled evaporator features an elongated tank with a built-in pipe system where cold water flows inside the pipes to extract heat from the cooling medium. The condenser coil is responsible for releasing the absorbed heat to the outdoor environment. Evaporative condensers are specialized cooling devices used in HVAC systems that combine heat exchange and evaporation to efficiently remove heat from refrigerant gases. These condensers use a combination of air and water to enhance the cooling process, achieving lower condensing temperature for improved system efficiency and energy savings. In conclusion, the selection of air or water as the cooling medium for evaporator and condenser is based on specific system requirements. with each medium offering distinct advantages in terms of efficiency, energy savings, and cooling capacity. Next slide po. Ang last application naman po ng heat exchanger is large steam system condenser. A steam condenser is a crucial component used in various applications, including power generation and brewing, to convert steam back into water. A steam condenser is a base closed vessel type heat exchanger that converts low pressure exhaust steam from turbines back into the water by removing its latent heat of vaporization. This process is essential for maintaining efficiency and reusing clean condensate in power plants. Steam condensers are essential devices used in different settings to convert steam back into water for use, contributing to energy efficiency and operational cost saving in power plants and industrial. Yan po, makikita nyo po yung picture po ng isang large steam system condenser po. Next slide po. There are two essential reasons why a steam condenser is necessary component of the steam cycle. First po is efficiency improvement. The steam condenser plays a crucial role in increasing the efficiency of the steam cycle by allowing the system to operate with the largest possible temperature and pressure differential. By converting used steam back into water for return to the steam generator or boiler as feed water. The condenser lower operational costs by enabling the reuse of clean and treated condensate. Additionally, it is far easier to pump liquid water than steam, contributing to overall system efficiency. A second reason naman po is cycle optimization. Another key reason for the necessity of a steam condenser is its ability to enhance the cycle's efficiency by facilitating operation with significant temperature and pressure differentials. The condenser allows for a larger delta T or the temperature difference and delta P the pressure difference within the cycle, which is essential for maximizing energy transfer and work output. This optimization is achieved through the conversion of used steam back into water, ensuring that the system operates at its peak efficiency level. Next slide po. Meron po tayong two types of steam condenser, the surface condenser and direct condenser. Surface condenser is a type of heat exchanger where the condensation of steam occurs on the external surface of cooling water tubes. It is commonly used in power plants to condense exhaust steam from turbines back into water. Surface condensers offer efficient aeration, lower pressure drop, and increased heat transfer area compared to direct contact condensers. They are suitable for applications where maintaining separation between the coolant and vapor is necessary. And another type po is direct contact condenser. In a direct contact condenser, the coolant comes into direct contact with the vapor, allowing for efficient heat transfer. This type of condenser is known for its simplicity in mechanical design and low cost. Direct contact condensers are smaller, cheaper, and have a simpler construction compared to surface condensers. They can operate in evaporation or condensation modes and find application in various industries like water distillation and chemical engineering. In summary, while surface condensers are more common in power plants due to their efficiency and separation capabilities, direct contact condensers offer advantages in terms of cost effectiveness, simplicity, and versatility in different applications like water distillation and chemical engineering. The choice between these two types depends on specific requirements such as efficiency goals, cost consideration, and the need for direct contact between the coolant and vapor. Next slide po. These large steam system condensers are straight-through, single-pass condenser that circulate cooling water through tubes from an inlet to outlet water box. Ito po yung design po ng isang large system steam condenser po. They maintain separation between water and steam areas through tube sheets and baffles to minimize direct impingement. A hot well collects condensate, which is then pumped out. Key components include the condenser, a condensate extraction pump, and a hot well for condensate collection before returning to the boiler. Condenser efficiency is measured by the ratio of actual temperature increase to maximum possible increase. Next slide po. The temperature and flow rate of cooling water through a condenser affect the condensate's temperature, which in turn affects its saturation pressure or vacuum. To prevent the condensate level from rising to lower tubes, a hot well level control system is used. This involves varying the flow of condensate pumps, controlling the speed of the pump or discharge flow control valve position, or using an overflow system. However, it is impossible to prevent the entry of air and non-condensatable gases into the condenser. To establish and maintain condenser vacuum, an air ejector or vacuum pump is needed. Next slide po. Yan po, makikita niyo po yung diagram po ng isang air ejector. Air ejectors are jet pumps or eductors that operate with two types of fluids. High pressure fluid flowing through the nozzle and the fluid being pumped around the nozzle into the throat of the diffuser. The high velocity fluid enters the diffuser, creating a low pressure area around the nozzle's mouth, known as entrainment. This process draws more fluid from the nozzle into the throat of the diffuser, converting velocity back to pressure. A single-stage air ejector can draw a vacuum of about 26 inches mercury using steam at a pressure between 200 psi and 300 psi. Air ejectors typically consist of two suction stages. The first stage suction on top of the condenser, and the second stage is suction from a diffuser of the first stage. The exhaust steam from the second stage must be condensed by an air ejector condenser, which is cooled by condensate and preheats the condensate returning to the boiler. Two-stage ejectors can draw vacuum to 29 inches mercury. That's all po.
Bali po ang link po ng Google Forms ay isasend lang po dito sa Google Meet. Bali makikiraise hand na lang po lahat ng mga tapos na magsagot po.
Okay, thank you so much, Group 8. So, kung wala na kayong concern, no? So next week is your midterm exam. Then, the week after that week, then online naman yon. So, wala man natin tayong gagawin. Then, week 11, no? Mag-i-start na tayo ng experiment natin. So, announce ko na lang sa GC if ever may kailangan kayong i-dalhin, i-ready, ano. So, yun. Lahat lang ng updates sa GC ko na lang ay i-send. Okay? So, good luck sa midterm weeks yun next week. Yun lang. Thank you so much.
Thank you po. Thank you po, sir.